Instead of using those traditional formulas, I'm going to label my triangle. In this one, I have a sum of squares. So sum of squares tells me that this is a hypotenuse. So I've got that this is a hypotenuse. If this is a hypotenuse, this means that the 1 or the 1 squared is a side. So I've got a side of length 1. And the 4x squared represents the other side squared. So my side is the square root of 4x squared, so that other side's length is going to be 2x. Let's go ahead and label our triangle, and then we can dive right into the trig substitution. Now that square root is my hypotenuse, and I recognize that right away because it's the sum of squares, follows the Pythagorean theorem. I've got a side here that's a constant, and the constant goes on the horizontal leg. My other side is the 2x, and that's going to go on my vertical leg. Now I'm going to go through and identify what trig function is going to replace each of my pieces. Now I'm going to use trig functions, so I'm going to use SOHCAHTOA, to identify what each of the pieces in my integral are in terms of a trig function. So I've got an x cubed, that's number 1. The second piece is the square root of 1 plus 4x squared, and piece number 3 is that dx. Let's go ahead and start with piece number 2. So piece number 2 is a square root. That lives on the hypotenuse. So I've got my hypotenuse. I need a trig function, so I've got to combine it with another side. I'm going to pick the easiest side, which is that number 1, and that's the side adjacent to theta. So I've got an adjacent and a hypotenuse. The CAH in SOHCAHTOA is cosine. So I've got cosine of theta is adjacent over hypotenuse, which is equal to 1 over that square root, 1 plus 4x squared. But I don't want the reciprocal of the square root, I want just the square root. So let's go ahead and flip these and take some reciprocals. The reciprocal of cosine is secant, so secant theta is equal to the reciprocal of our fraction, which is going to be the square root of 1 plus 4x squared. So that gives us one of our pieces, and we numbered that piece number 2. Okay, so check. Next, I need an x cubed, and I can get to the x cubed using an x off of my triangle. Moving back over to my triangle, I see that I've got a 2x here on the side opposite from theta. I again want to combine it with the easiest side possible, and that's going to be our adjacent side. So for the x, I've got an opposite and an adjacent, and that comes from TOA, which is tangent opposite over adjacent. So let's do the tangent next. So the tan of theta is opposite over adjacent, which is equal to 2x over 1. I want to go ahead and take that tan theta and divide both sides by 2. So I end up with tan theta divided by 2 is equal to 2x divided by 2, and there is x. So x is equal to tan theta divided by 2. But that wasn't exactly what I wanted, right? There it is. I actually wanted x cubed. So let's go ahead and cube this so we can get to the next piece of our substitution. So as I cube this, I've got x cubed is equal to, I need to cube the tangent, so that's going to be a tan cubed theta, and then cube that 2 as well. 2 cubed is 8. There's another piece that I needed. Checking back in with my integral, I've got just that last piece, which is our dx. Well, to get to the dx, I'm going to use what I found for x and take its derivative. So let's go ahead and take this, what we had for x. X is tan theta divided by 2. So that tells me that dx is equal to the derivative of tangent, which is secant squared theta d theta, and that divided by 2 just stays put. So now I've got all 3 of my pieces. Let's go grab that integral and do the substitution. So I went ahead and grabbed my integral and each of my substitutions. So I've got number 1 is my x cubed, that one's right here. Number 2 is my square root, that one's right here, that's secant. And then number 3 is right here, and that's that dx. So we can put this together in terms of theta now with our trig substitution. So this becomes the integral of x cubed, but x cubed is tan cubed theta over 8. So that's going to be a tan cubed theta divided by 8. Now I move on to piece number 2, which is the square root. The square root is right here. That's going to be a secant theta. So I've got a secant theta there. And then finally my dx. My dx is right here, and that is a secant squared theta divided by 2 d theta. Let's continue to work through this. Combining what I've got, let's bring that 8 times 2, that's a 16. Let's bring that out in front as a 1/16. I can think of that as a 1 there. So I've got 1/16, and then I have a tan cubed theta, secant cubed theta d theta. So I need to do a u substitution next, and I want to think about what my potential candidates are for a du. When I'm taking derivatives of trig functions, I can end up with a tan or a secant if I do the derivative and get a secant squared theta. That would be from a tangent. But I could also use a secant theta tangent theta. And this one would be from the derivative of a secant. The other thing that I've got to consider here is that I need to use the Pythagorean identities to get everybody else in terms of whatever I'm going to let my u be. So I have a couple of options here for du, but I'm also thinking about what u is going to be. So it turns out, because I've got those odd powers, that I want to pull out one secant and one tangent to be part of my du, and that's going to leave me with secant squared and tangent squared, which is going to allow me to use the Pythagorean identities. So rewriting this, I've got 1/16. I'm going to pull out one tangent, so that's going to leave me with a tan squared, a secant squared, and then I've got a tan secant. If I have enough room, and then my d theta. Okay, so this is going to be my derivative. So my du here is a tangent secant, which means that u needs to be a secant. So everything over here needs to be in terms of secant. I'm just about there. Secant squared is already there. I just need to get to my tan squared. Let's go ahead and use a Pythagorean identity. While I don't have all the Pythagorean identities memorized, I do always remember that sine squared plus cosine squared is equal to 1. I really need to get my hands on a tangent squared, so I'm going to divide everybody by a cosine squared. Cosine squared, cosine squared. Okay, so what does this give me? It gives me that tangent squared. So I've got a tan squared. I'm just simplifying a little bit here. Cosine squared divided by cosine squared is 1. And 1 over cosine squared is secant squared. I'm solving for tangent squared, so if I subtract a 1 from both sides, I have tangent squared theta is equal to secant squared theta, just enough room for my minus 1. Replacing that, here is what we get. So I get a 1/16 out in front. That tan squared becomes our secant squared minus 1, so secant squared theta minus 1, times our secant squared theta, and then I've got my tangent secant, so tan theta secant theta d theta. Okay, so like we said before, this is our du, secant is our u, and I've got everything there in terms of secant. So I'm ready for my u substitution. We end up with a u substitution, 1/16. Pause for just a second, think of what we're doing. We started out with everything in terms of x. Then we went to everything in terms of theta using a trig sub. Now I'm doing a u sub. But the beauty here is it's going to make it so easy. So as I bring that u substitution into my integral, the secant gets replaced with u. So I have u squared minus 1 times a u squared times tangent secant, which is the derivative of secant. So that's going to be our du. Let's go ahead and distribute that u squared so I can do a really nice power rule. And I get u to the fourth minus 1 times u squared, which is u squared, du. Now I'm ready to integrate. So 1/16 finally integrating. U to the fourth, the 4 gets bumped up to 5. So u to the fifth divided by 5 minus u squared, it gets bumped up to 3 and then divided by 3. And then we've got our plus c here. I'm going to distribute that 1/16 through. 1 times u to the fifth is u to the fifth. 16 times 5 turns out to be 80. Minus sign in the middle, and then 1 times u cubed. So I get u cubed divided by 16 times 3, which is 48 plus c. Now this is an answer, but it's in the wrong form. What we really need to do here is to go back in terms of theta, and we can do that by undoing our u substitution, and then I'm going to go back in terms of x. Let me grab that u substitution that we were using earlier. We know that u is equal to secant theta. So I'm going to replace u with a secant theta in both of those fractions. So u is secant theta. So we've got, so I'm doing this back in terms of theta. So this is going to be a secant to the fifth theta divided by 80 minus u cubed, but u is secant, so that's going to be a secant cubed of theta divided by 48 plus c. Okay, so we've done the conversion to theta. Now I've got to do the conversion to x, and that means that I need to go to my original triangle. You can also go all the way back up to your work and find what you used for x. Our triangle looked like this. We had a 2x here, a 1 here, and a square root of 1 minus 4x squared here, and this was theta. I want a secant because cosine is adjacent over hypotenuse. I know that secant theta is its reciprocal, so that's going to be hypotenuse over adjacent. Hypotenuse is my square root, adjacent is 1. So I end up with my hypotenuse, which is 1 minus 4x squared divided by 1. So I'm going to replace secant theta with the square root of 1 minus 4x squared. I've got a secant theta here and a secant theta there. Believe it or not, we are almost to our answer. So taking what we had here as, again, an almost answer, I'm going to go back in terms of x now. Secant to the fifth. So this is going to be a square root of 1 minus 4x squared all to the fifth. So that's my secant to the fifth divided by 80 minus secant cubed. So that's my square root of 1 minus 4x squared all cubed divided by 48, and that's going to be a plus c. You probably won't see it in this form. Instead, we can replace that square root with a 1/2 power and a 1/2 power. So I'm just going to leave you with a more common form of that answer. 1/2 times 5 gives me a new 5/2 power, multiplying those powers together. So I'm going to replace the square root with my 1/2 power. I get 1 minus 4x squared all to the 5/2 power divided by 80 minus 1 minus 4x squared, replacing that square root with a 1/2 power. 1/2 times 3 is 3 over 2, all divided by 48 plus c. How did you do? If you were able to follow me, you are doing so well. Take a look at this next video here. Thank you so much for watching.